financial department back home in order to see this information. At that point, we can renegotiate trust. So in this diagram, we've got step one. We've already performed. That's when Alice first tried to access the network and ended doing was sent off to do a trust negotiation with the authorization server. Later on, if she tries to access this financial subnet that has sales data, she'll again get referred to the authorization server. Trust can be negotiated again, and if she can satisfy this more restrictive policy, fine. She'll be given access to this additional subnet. Okay, again, key points: iterative, bilateral, and automated. We've just seen that you can renegotiate trust on the fly as needed as time goes on. And we also have ways that you'll see in the demo of protecting sensitive requests for resources and also for protecting sensitive information that's in policies. Okay, so what we've been, so in my early years working on this, I had a PhD student who was theoretically oriented, and we did theoretical work. That student has graduated, and with my current students, we're focusing on some more practical questions. Basically, we are trying out trust negotiation in various real-world situations and seeing what else is needed in the real world. So the area where we're furthest along is in trying out trust negotiation in high-performance computing grids. Since I come from the University of Illinois, high-performance computing is very important there, and NCSA, National Center for Supercomputing Applications, has high-performance grids right next door to our building. So I've been working with two people from NCSA, Jim Basney and Vaughn Welch, on trying trust negotiation out with the idea that maybe it could become part of the grid security infrastructure, which currently is just based on identity. It's not access control, it's based on identity, not on people's attributes. So the two main research directions that have emerged from that work so far are, first, we need a very graceful way of making trust negotiation available to all the things that are already on the grid and don't know about trust negotiation. And towards this end, we have built a standalone authorization service called Traust, and I'll be showing you a demo of that in just a little bit. And with this standalone service, legacy clients and legacy servers can still take advantage of trust negotiation. The second direction we found is important on the grid is that you really need trust negotiation, as you've seen in our examples, it's between two parties. But in the real world, you often need to involve additional parties at runtime who want to help, who have useful information that you need, and you need to involve them in the process. So how to do this in a graceful way is the subject of our work on PeerTrust2, which I'll also talk about today. And high-performance computing isn't the only area where we've been trying out trust negotiation. We've also been looking at computer networks, like the example we used, admission control on networks, and also new research problems that might be posed by the way that people would use trust negotiation on the corporate intranets of very large companies. Okay, so I'll be showing three demos at this point. The first two are demonstrations of TrustBuilder, which is our software for runtime trust establishment. And what you'll be seeing is trust negotiation added to TLS. Okay, so by extensions to TLS's re-handshake facility, trust negotiation will be taking place on the fly as we access a website. And this demo is brought to you by my colleagues at Brigham Young University Internet Security Research Lab in Kent Siemens Group. TrustBuilder uses IBM's trust policy language and trust engine software internally, and you'll see how that fits into the overall agent on my next slide. The third demo that I'll show you is of Traust, that standalone authorization service that makes trust negotiation available for legacy clients and also for trust-aware clients and legacy and trust-aware servers as well. In that demo, the trust negotiation will not be running inside TLS. It will be running on top of TLS using something called the Traust protocol that I'll talk about later. And Traust also makes use of TrustBuilder and IBM's TE and TPO. So before I show you the demo, I'd like to just say a little bit more about what you'll be seeing in the TrustBuilder demo. Both the parties involved in this demo will be running these security agents. And the security agents have several internal components. Okay? The major internal components are shown in blue, these three blue boxes. And the simplest of those components is the credential verification module. And when someone gives, and this particular agent belongs to Alice, so when someone sends Alice credentials, for example, Bob, those credentials are checked by the verification module to be sure that they haven't been tampered with and the signatures really are by the person they're supposed to be by. Okay? And if they pass the verification test, they can be passed on, and they'll probably make their way down to this policy compliance checker, which can check to see if the credentials that Bob has sent satisfy any of Alice's relevant access control policies. Okay. This same module is also used in a different way to see if the policies that Bob has sent over to Alice, up on the top left corner, to see if Alice could satisfy those with any of her credentials. The compliance checker also checks for that. And then the negotiation strategy module is the brains of the outfit. It decides at runtime exactly what it should send to the other party next during the negotiation by making strategic decisions. Okay, so I'm going to bring up our first demo. So here I'm running an ordinary web client, except that I have edited the preferences so that I'm running a security agent. And that security agent is running as a proxy on this machine. Okay. All right. So let's cancel that because I've already turned on the proxy. And I'm going to go to a website that's being served by a web server that I started right before our meeting here began. So that web server is also running on my laptop right here. Okay. So this web server is running a modified version of Apache Tomcat that has a security agent built into it. And my proxy is going to act as my security agent. So we've got these two security agents, and they're going to talk to each other in the following way. So this website represents a wholesale pharmacy. It's a place that pharmacies can go to when their stocks are running low to buy additional drugs. So let's pretend for the moment that I work for one of these retail pharmacies and I need to buy more stocks of one of these wonder drugs, say Ridicin. Down at the bottom, my credit card number is already filled in and I can press the order button to order it. When I do this action, there are access control policies associated with it. We don't want consumers just buying any drug they want over the internet. So to buy from this wholesale pharmacy, you have to be a retail pharmacy, and that means you have to be licensed by the Board of Pharmacy. Okay. So in the background, you'll see a couple of windows. These are Java windows. And one of them is the window for the security agent for the client, and the other is the security agent for the server. And when I click on the Submit button, you will see them going back and forth, and you'll see the printout from the negotiation that's taking place in the background. So let me go ahead and click Order Now. So the negotiation was successful because I had the credentials needed to buy from the wholesale pharmacy